Hi everyone, welcome to 5.5. Before we jump into the lesson though, I have a nice little comic joke for you to remind you about the relationship between integration and differentiation. The derivative of Batman is Bruce Wayne, but the integral of Bruce Wayne is equal to Batman. Alright, so 5.5 is the substitution rule. We've got one objective here, and that is to learn how to use U substitution. Okay. So, in class the other night, we looked at the one-step integrals, but there are going to be times when integrals won't be one step, so we need to learn some other methods. Some of the other methods are U substitution and integration by parts. What we're going to learn now is U substitution, but integration by parts will happen in Calc 2. Okay? So the substitution rule tells me that if U equals g of x is a differentiable function whose range is an interval I, and f is continuous on I, then the integral of f of g of x times g prime of x dx equals the integral of f of u du. So essentially what's going on here is we're going to take our integral that's going to start with a variable of x, and we're going to rewrite it in terms of a new variable u. Notice here that in my initial integral, one of the ways or a hint that we can tell that we need to use U substitution is that the derivative is somewhere in the problem. So essentially what's going on here is it's almost like we're undoing the chain rule or the opposite of the chain rule. These two are kind of partnered together. Alright, so here's our first example. We have the integral of 2x square root of 1 plus x squared dx. So here's what's going to happen in U substitution. You have your integral in terms of x's, so we're going to call this x world over here. And that integral is the integral of 2x square root of 1 plus x squared dx. And we are going to go through this magic box, which is going to enter us into U world. Now, in this magic box, we need to come up with a u in relationship to the x's we already have in our initial integral in x world. So in this case, our u is going to equal 1 plus x squared. Now, in terms of figuring out which part of your initial integral needs to be your u, remember that you're looking for the derivative of it to appear somewhere else in the problem. So if I take the derivative of 1 plus x squared, I'm going to end up with 2x. Now, think back to, I believe it was 3.10 when we talked about linear approximation and differentials. What we're doing right here is we're finding a differential. So we're going to write underneath this that du equals 2x dx. Now, the reason we wanted to do that is because we need to make sure that when we go through from x world to u world, we take all of our parts. So we already had the 1 plus x squared, but we still needed to make sure that we were able to take over the 2x and the dx. Okay, so make sure you get all your parts there, and that's why we end up taking the differential. So let's bring it all through. The integral of 2x times the square root of 1 plus x squared dx comes over into U world as the integral of the square root of u. Okay, there's my square root of 1 plus x squared. And now I still need to make sure that I bring over my 2x dx. But if we look in this box, 2x dx equals du. So we're going to bring that over as du. Okay. Now I need to take the integral while I'm over in U world of the integral of the square root of u du. This is a one-step now. So the whole reason we're doing u substitution is that once we get the integral over into u world, it becomes a one-step. But it's not a one-step until we do that substitution. So we could rewrite this integral as, let's see, the integral of u to the 1/2 du. Because remember, a square root is the same as an exponent of 1/2. And now let's take that integral. We're going to get u to the 3/2 over 3/2. And we could rewrite that as u to the 3/2 times 2/3. Remember, dividing by a fraction is the same as multiplying by the reciprocal. Okay. Now, I need to take that 2u to the 3/2 over 3 back through this box to get my final answer back in terms of x's. So 2 comes over for free because it's a constant. My u now gets replaced with that 1 plus x squared to the 3/2, and my 3 in the denominator comes over as well. And don't forget, we always have to remember our plus c. So the integral of 2x square root of 1 plus x squared dx is equal to 2 times the quantity 1 plus x squared to the 3/2 over 3 plus c.